Chapter 3, Motion in a Straight Line. Motion in a straight line, we are taking question and answer of motion in a straight line. The first is, in which of the following example of motion can the body be considered approximately a point object? A railway carriage moving without jerks between two stations. So if two stations are long apart, then we can take the railway carriage as point object. A monkey sitting on top of man cycling smoothly on a circular track. So if it is a circular track, a monkey is on the top of a man which is cycling. So with respect to the circular track, the monkey, the size is less. So you can consider the monkey as a point object. A spinning cricket ball that turns sharply on hitting the ground. So now the ground, that is the pitch, if we are talking about pitch, the ball has a substantial size. Here we cannot take the spinning cricket ball as point object. A tumbling beaker that has slipped off the edge of a table. When you talk about a table and a beaker, then you see that this object is somewhat comparable to the size of the table. So you cannot take it as a point object. This is what is being discussed here. The position time xt graph for two children A and B returning from their school. Oh, if this is a school, this is the graph of A, this is graph of B, and their houses are at P and Q. We have to correct the choose the correct entries from this A/B, A/B or B/A. The first is AB lives closer to the school than the BA. See, A has to go to P. So A is closer to O rather than B, because OP is less than OQ. He has to go up till this distance, right? So we can say that A lives closer than B. Then AB starts from the school earlier than BA. Here A starts at t equal to 0, but B starts afterward, after some time. So we can say that this AB means A starts from school earlier than B. So we'll choose A and then here B. AB walks faster than BA. See, the time A has reached here, the B, although he has started later, but he has crossed somewhere, or he has reached the house. What time we'll see, but he is walking faster, because as you see from the graph, this B walks faster than A. A and B reach home at the same time or different time. If you see here, if this is a time, so if you draw a line here for time or t, you see that both are same. So they are both reaching at the same time. AB overtakes BA on the road. So B overtakes A on the road because B is faster than A. So this is what is being discussed all here, that A lives closer than B, A starts from school earlier than B, B walks faster than A, and A and B reach at the same time, and B overtakes A once on the road. How many times they are meeting? Because they are just crossing once, so you can say they are crossing once. So B is overtaking A once. After that, they reach their home. A woman starts from her home at 9 a.m., walks with a speed of 5 km an hour on a straight road up to her office 2.5 km away. Stays at the office up to 5 p.m. Returns home by an auto with a speed of 25 km an hour. Choose suitable scales and plot the xt graph of her motion. So what is happening here is, the woman is starting at 9. Then by 9:30, this is the xt graph. So by 9:30 she reaches here at 5 km. Then she stay in office from 9 to 5. And then in just few minutes, because the speed of the auto is 25 km an hour. So she reaches at this time, 6 minutes actually. We'll find out this distance, or you can say we will find out the time also. This is the graph. We are choosing from 9 to 5, and in between also we can have 9:30, 10, 10:30 like this. Here, because we have to go up to 5 kilometers, so we have taken the x in kilometer till 5 kilometers. Now let us see what is happening. When she is walking Speed of the woman is 5 km per hour. The distance is from here to here 2.5 km, means from her house to the office. So the distance is 2.5 km. We know that t equal to d by s, time equal to distance by speed. We'll just put these two values and we say that this is 0.5 hour. 0.5 hour or half hour is just 30 minutes. Now she has to cover the same distance, that is 2.5 km will remain same. But now the speed has changed, it is 25 km an hour. Again we'll apply the same formula, it will be 6 minutes. That is 1 by 10, 1 by 10 is 0.1 hour. 0.1 hour, change it into minutes, 60. So it gives you 6 minutes. So this is the 6 minutes. This is the plotting of the graph. A drunkard walking in a narrow lane take 5 steps forward and 3 steps backwards. So 1, 2, 3, 4, 5 he takes forward and he comes back 1, 2, 3. So eventually he is taking only 2 steps per walk, coming and back, means moving forward and backward. So this happens again and again. Each step is 1 meter long and it requires 1 second. So 1 meter, one step, 1 second. We have to plot the xt graph of the motion. We have to determine graphically or otherwise how long the drunkard takes to fall in a pit 13 meter away from the start. So we have to start from here. We have to see how much time it needs for him to go up to this 13 meter. We know that every time he walks for 2 meter only, because he walks forward for 5 steps, then he comes back. So 2, 2, 2 like this, and just 1 meter is remaining. We'll see about that. The distance covered in 1 step is 1 meter and time taken is 1 second. As we said, the time taken to move first 5 meter forward, because 1 meter is 1 second, so it is 5 seconds. And time taken to move 3 meter backward, which is simply 3 seconds, because he comes back. So net distance he covers is 5 minus 3, as I suggested here, 2 meter. But as I said that he only walks for 2 meter, but 1, 2, 3, 4, 5, and then he comes back 3 again. So in all, 5 plus 3, that is 8 seconds he takes for one forward and backward step. So he covers 2 meter in 8 seconds, 2 in 8 seconds. So it will be 4 in 16 seconds. So it will be 6 in 24 seconds. Then 6 plus 4 plus like this. Okay. So we can just say that in 6 meter he is going 24 seconds, and you can also say that in 8 seconds he goes 32. This is simply, just in 2 it is 8. So what will be 4 in 4? We are multiplying 8 by 2 here. Just simply interpolating it. Now in 8 seconds he is walking for 32 seconds. Now we want for 13 seconds, so it has to be 8 plus 5. So 8 seconds we have obtained, it is 32 seconds. How about 5 seconds? So in 5 seconds the drunkard will cover 5 meters. So total distance of 13 meters. After that he falls to the pit. So 32 is this 32 seconds, then again 5 seconds he takes. So 32 plus 5 is 37 seconds. So this is how total value will be. Now the graph will be of zigzag. It will be quite easy. This is the time, this is the x. We have taken from 2 to 14. From here we have taken from, say, up till 40. Now he goes like this, then he returns like this. Then he goes like this, he returns like this. Means this is 5 steps, 5 seconds. Then again he comes back 3 steps, so 3 seconds, so it will be 8. Like this zigzag it goes. A jet airplane traveling at a speed of 500 km an hour ejects its product of combustion at the rate of 1500 km an hour relative to the jet plane. So if jet plane is moving like this, then it is, because the speed is 500 of the jet plane, it ejects the combustion, means you can say the smoke coming out of it, you can say like that. It is 1500 km an hour. What is the speed of latter with respect to an observer on the ground? So when the observer is here, he sees that because it is going at 1500 and this is at 500, so we'll see there will be a difference of these two. So the speed of the jet airplane is given as 500 km an hour, but if this is plus, this has to be negative. So this is the relative speed of the product. This product which is coming out of combustion with respect to the plane will be what? This is minus. If this is plus, this has to be taken minus. So we smoke you can say will be minus 1500 km an hour. Now speed of the product of combustion with respect to the ground will be what? For him, let us assume to be V dash smoke. And we know that the relative speed of its product of combustion with respect to the plane will be what? V smoke will be simply V dash smoke minus V jet. We want to find V smoke, so just take this one here. It will be minus 1000. And why? Because if you subtract this also, 15,000 minus 500, this will be relative. And because this is in opposite direction, it will be minus 1000. So this seems very obvious here, but this has to be taken. This has to be used in a way which has been taught to us. So the negative sign indicates that the direction of its products of combustion is opposite to the direction of motion of the jet airplane. A car moving along a straight highway with speed 126 km an hour is brought to a stop within a distance of 200 meters. So distance is given, the speed is given, and rest, that means it is coming at rest. So initial velocity is this, final velocity is 0. What is the retardation? We have to find A, that is deceleration. How long does it take for the car to stop? So we'll simply use the formula. The initial velocity is 126 km an hour, multiply it by 5 by 18. You get in 35 meter per second, which is in conversion from kilometer per hour to meter per second. Just multiply this by 5 by 18. As I said, the final velocity has to be 0 because it is coming at rest. Now, what is the distance covered by the car? It is given as 200 meters. We assume it to be A. The retardation acceleration in the negative direction is A. Now, we know that the equation of motion V square is equal to U square plus 2AS. Put this value, you get A equal to minus, because this is deceleration, you get minus 3.06. Again, we'll use the first equation of motion V equal to U plus AT. Put this value, okay. A you know, V and U you know. So this will be 11.44 seconds. Two trains A and B of length 400 meters, each are moving on two parallel tracks with a speed of this, in the same direction, with A ahead of B. So you can say that there are two parallel tracks, and one is moving like this, other is moving like this. The driver of B decides to overtake A and accelerates by 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? So after 50 seconds, this is very important, this has to be taken into account in the question, that after 50 seconds when he increases the speed of 1, or you can say acceleration to 1 meter per second square, or attain 1 meter per second square acceleration, after 50 seconds this guy sees the back of the train, or you can say the driver sees the guard. So what is happening here is, first we will start with train A. The initial velocity is 72 km per hour, multiply it by 5 by 18, you get 20 meter per second. Time is 50 seconds, acceleration is 0 for this one. There is no acceleration. The acceleration is for B. Okay. So we'll use the second equation of motion. We'll use S1 equal to ut plus half a t square. A1t square, you can say. A1 is 0. So just multiply 50 with 20, you get 1000 meters. So in this time 50 seconds, the train A has moved 1 kilometer. But when we are talking about train B, again the speed is same, 72 km an hour. So this will be in meter per second, 20 meter per second. But this train is having an acceleration of 1, and time is again same as the previous one, 50 seconds. So we'll apply the second equation of motion, S equal to ut plus half a t square. We will apply this, and we see that it is 2250. Now 2250 A has moved, 1000 B has moved. So how far this has moved, or how far this is ahead? This is, or you can say what was the initial distance? Just subtract these two, you get 1250. On a two-lane road, car A is traveling with a speed of 36 km an hour. Two cars B and C approach A in opposite direction. So A is here. Say B is coming from this side and C is coming from this side. And say A is moving like this. A and B are in the same direction. C is on this direction. The speed of these two, B and C, is given as 54 km an hour. At certain instance, when the distance AB and AC are equal, that means this distance is equal to this distance, both being 1 kilometer. So this is also 1 kilometer, this is also 1 kilometer. B wants to decide that, okay, I want to overtake A before C does, because they are coming in the opposite direction. So B has to attain certain speed or acceleration, something, so that there is no collision. So B has to surpass this before C reaches here. So what will we see here? Velocity of car A is 36 km an hour. Multiply it by 5 by 18, you get 10 meter per second. How about car B? VB is 54 km an hour, which is 15 meter per second. So velocity of car C will be again same thing. So 15 meter per second, because B and C are having the same speed. Now what is the relative velocity of car B with respect to A? Because these are in opposite direction, right? So one is coming at 15, this and you can say that when you are comparing B with A, so it will be VB minus VA. One is having 15, other is having 10, so it will be 5 meter per second. But when we are talking about C and A, then we say, okay, because they both are in this direction. When they are coming, because one is, if this is taken as plus, this has to be taken as minus. So in this case, we'll take minus V. The speed will increase. When they are opposite, the speed increases. So VC minus VA, this is the relative velocity of C with respect to A. 15 plus 10, that is 25 meter per second. But we know that the distance between AC and AB are 1000 meter, 1 kilometer. So time taken, because C is at constant or uniform speed, you just have to find out 1000 by 25. That is, you have to find T equal to distance by speed. So this is 40 seconds. Now this is very important. At this time, 40 seconds, this car reaches to this car. But the thing is that this car wants to overtake. So in this 40 seconds, which car this wants, this is coming here. In this 40 seconds, in order to avoid an accident, the car must cover the same distance in a maximum of 40 seconds. And the second equation of motion, minimum acceleration, we can obtain it as like this: x equal to ut plus half at t square. So the distance he has to cover is 1 kilometer. But the speed, we know 5 into 40, that 5 is there. But 40 is the time. In this time, he has to do something, or some acceleration has to be there. So what is the proper acceleration? A has to be found out using this formula. It will be 1 meter per second square. Two towns A and B are connected by a regular bus service, with a bus leaving in either direction every t minutes. So say A here, B here, every time in t minutes, bus starts from here, bus starts from here. Now a man which is cycling with a speed of 20 km an hour. Say somebody is cycling also 20 km an hour in the direction A to B, notices that the bus goes past him every 80 minutes in the direction of his motion. So the bus moving like this will be every 18 minute difference. But the bus which are coming from here, they pass every 6 minutes in the opposite direction. So what is the period T of the bus service, and with what speed do the bus ply on the road? So what we will do here is, if let us take capital V is the speed of the bus which are running from A to B, which are given as the normal speed of the buses. The speed of the cyclist is given as 20 km an hour. What is the relative speed bus which are moving in the direction of the cyclist? So when the relative speed bus which are moving in the direction of cyclist, it will be V minus V, that is V minus 20. And the bus are passing every 18 minute. So 18 minute will be 18 by 60 hour. What is the distance traveled? Distance traveled is simply velocity into time. So this will be the first equation. Now since every bus leave after t minutes, it is given every t minute it passes, the distance traveled by the bus will be equal to V into t by 60, right? Now both equation, these two are equal, so let us equate them. This is equal to this. Let us talk about the other aspect. The relative speed of the bus moving in the opposite direction. Cyclist is moving like this, the bus is coming like this. So the relative velocity will be V minus of minus 20, that is V plus 20. The time taken means every 6 minutes he sees a bus. 6 minutes will be 6 by 60 hour. And what will be the scenario? The time it was Vt by 60, because every t minutes also this is coming. So this will be V in Vt by 60 again, but here V into 20, V plus 20 into 6 by 60 will be equal to Vt by 60, as we did in the previous which was on the same direction of the cyclist. Now let us equate this equation with this equation. That is equated. When we equate it, we find V equal to 40, and just substitute this in any of these, this one or previous one, we get time equal to 9 minutes. A player throws ball upward with the initial velocity 29.4. Like this. It throws. What is the direction of acceleration during the upward motion of the ball? So gravity is like this, so it is on the opposite direction. What are the velocity and acceleration of the ball at the highest point of its action? So at highest point it goes and it comes back. So here the velocity will be 0. It will take rest for very short span, but the acceleration is always there. It is gravity. We have to choose x equal to 0 and t equal to 0 to be the location and time of the ball at its highest point, vertically downward direction to be the positive direction of x-axis, and give the signs of position, velocity, acceleration of the ball during the upward and the downward motion. To what height does the ball rise and after how long does the ball return to the player's hand? G is given as 9.8 and neglect air resistance. What is happening here is the direction of the acceleration, as I said, is always to the center of the earth, and because there is a upward motion, the acceleration will be downward. So velocity is 0, acceleration equal to 9.8. X is greater than 0 when it is going up and down. V is less than 0 for up. V is greater than 0 for down, because here it is going to stop at some time and here it is going to, because of acceleration, it will gain some speed. And acceleration is greater than 0, which is actually 9.8 constant value throughout the motion. And what is this? This is the time. I'll show you how it comes. So this is all the discussion which I just told you. Let us come to the computation part. So when it goes up, the initial velocity is given as the 29.4 meter per second. Final velocity has to be 0 because it is going to stop. The acceleration is, because it is always on the downward direction, acceleration will be minus z. It is minus 9.8 meter per second square. And we'll apply the third equation of motion, v square equal to u square plus 2gs, and s will be simply like this. We'll just put the values, and this will be 44.1 meter. And we know that the time of ascent is equal to time of descent. We can apply v equal to u plus at, and the time will be 3 seconds. I leave it for you. But when it goes up 3 seconds, it comes down, it is 3 seconds, 3 plus 3 is 6 seconds. Read each of the statement below carefully and state with reason and example if it is true or false. A particle is in one dimension motion with 0 speed at an instant may have non-zero acceleration at that instant. With 0 speed may have non-zero velocity. With constant speed must have 0 acceleration. With positive value of acceleration must be speeding up. So first one is our true. Second is false, then true, then false. So let us see how does it happen. True, false, true, false. First is with 0 speed at an instant may have non-zero acceleration at that instant. So when an object is thrown vertically up in the air, its speed becomes 0 at maximum height. But at this point also the acceleration is 9.8 due to gravity, which is acting on the downward direction. First one. Second is this one. With 0 speed may have non-zero velocity. So speed is the magnitude of velocity we know, and when the speed is 0, the magnitude of the velocity along with the velocity is 0. That is why it is false. A car moving on a straight highway with constant speed will have constant velocity. Since the acceleration is defined as the rate of change of velocity, the acceleration of the car is also 0. That is why it is true. How about this one? See, this statement is false. With positive value of acceleration must be speeding up. So the statement is false in this situation when the acceleration is positive, velocity is negative at any instant of time you take from the origin. So for all the time before velocity becomes 0, there is, the particle is slowing down. So such a case will happen when a particle is projected upwards. And this statement is true, that is, when both velocity and acceleration are positive at the time taken as origin. So this case happens when a particle is moving with a positive acceleration and falling vertically downward in this case, right? So this is the first discussion of the question answer, and we'll be taking one more. Till then, thank you so much. Take care of yourself.